You're lying in bed, the lights are off, the house is quiet, and then you hear it. A creak. Somewhere downstairs. Your whole body goes still. Your heart rate spikes, your ears strain to catch the sound again. For a few seconds, you're not a person scrolling through your phone an hour ago. You're something much older, something listening for danger in the dark. And here's the strange part. There is almost certainly nothing down there. No threat. No intruder. Probably just the house settling or a pipe cooling down. But your brain didn't check with you first. It reacted instantly, automatically, before you even had time to think. So why does a sound in an empty house still do that to you? This is Kainos DMT-Lounge, where we have deep, meaningful talks. And tonight, we're asking why your brain still behaves like you're being hunted, even though, statistically, almost nothing is hunting you anymore. To understand this, you have to go back, way back. For most of human history, the world was not safe. Predators were real. Other tribes were real threats. Disease, starvation, falls, snake bites, all of it was constant background risk. In that world, a brain that reacted instantly to danger had a massive advantage over a brain that stopped to think things through. Imagine two early humans hearing a rustle in the grass. One pauses, calmly considers the possibilities, weighs the evidence. The other freezes immediately, heart pounding, ready to run. If that rustle was the wind, both of them are fine. But if it was a predator, only one of them survives to pass on their genes. Over hundreds of thousands of years, that pattern repeats itself, again and again and again. The cautious but slow brains gradually disappear from the gene pool. The fast but jumpy brains stick around. In the 1920s, a physiologist named Walter Cannon gave this reaction a name you've probably heard before: fight or flight. He described how the body floods itself with stress hormones the instant it perceives danger. Heart rate increases, breathing quickens, blood moves away from digestion and toward your muscles. Your senses sharpen. All of this happens in a fraction of a second, long before your conscious mind has even finished processing what's going on. Decades later, a neuroscientist named LeDoux mapped out exactly how this happens inside your brain. He found that sensory information, like a sound or a shape in the dark, doesn't go straight to the rational, thinking part of your brain first. It goes to a small, almond-shaped structure called the amygdala. The amygdala's entire job is threat detection, and it is fast, faster than conscious thought. By the time your prefrontal cortex, the part of your brain that reasons, plans, and says, "Wait, that's probably nothing," finally catches up, your amygdala has already sounded the alarm. Your heart is already racing. Your body is already preparing to fight or run. In other words, you don't feel afraid and then react. You react and then you feel afraid. This system kept your ancestors alive, but here's where things get strange. Your environment has changed almost completely. Your amygdala hasn't. Think about what actually threatens you on a daily basis now. It's rarely a predator. It's an email from your boss, a red notification badge, an unknown number calling late at night, an awkward silence in a conversation. None of these things can physically hurt you. But your amygdala doesn't know that. To your amygdala, a slightly aggressive email and a literal predator can trigger a remarkably similar response. Elevated heart rate, tense muscles, a flood of stress hormones, a mind that suddenly can't think about anything else. A researcher named Robert Sapolsky spent decades studying this exact mismatch. He studied zebras in the wild and noticed something important. When a zebra escapes a lion, its stress response activates fully and then switches off almost immediately once the danger passes. The zebra goes back to grazing within minutes, as if nothing happened. Humans are different. We can activate that same stress response just by thinking about something. A conversation that hasn't happened yet. A mistake we made 3 days ago. A what-if that has a 1% chance of ever occurring. Your body can't always tell the difference between a real threat and an imagined one, which means you can trigger the exact same biological alarm system that once helped your ancestors escape a predator, just by replaying an awkward text message in your head at 1 a.m. So why doesn't this system just turn off? Why hasn't evolution caught up? The answer comes down to a kind of cost-benefit imbalance, one that's been studied extensively under what researchers call negativity bias. A psychologist named Roy Baumeister, along with his colleagues, reviewed decades of research and found a consistent pattern. Bad experiences affect us more strongly and linger longer than good ones. One piece of criticism can outweigh 5 compliments. One mistake can dominate your thoughts more than 10 successes. This isn't a flaw. It's a feature. Because for your ancestors, missing a threat could mean death, but missing an opportunity usually just meant a missed opportunity. There would be others. So a brain that overreacts to danger, even when it's wrong most of the time, still comes out ahead. A brain that underreacts to danger, even just once, might not get a second chance. In evolutionary terms, false alarms are cheap. Being eaten is not. So your brain was built very deliberately to assume the worst first and ask questions later. Now think about what that means for your daily life. Every notification, every unread message, every slightly off tone of voice from a friend. Your ancient alarm system treats all of it through the same lens it once used for rustling grass and unfamiliar footsteps. It's not broken. It's doing exactly what it evolved to do. It's just doing it in a world that no longer matches the one it was built for. This is why you can know, logically, that there's nothing to worry about, and still feel your heart pounding anyway. Knowing doesn't switch off the alarm, because the alarm isn't located in the part of your brain that knows things. It's located in the part that reacts first and explains itself later. So the next time you feel that jolt of anxiety over something small, a notification, a silence, a sound in an empty house, it might help to remember what's actually happening. You're not overreacting. You're not broken. You're running incredibly old software on incredibly new hardware. A system built for lions, snakes, and rustling grass, now running in a world of inboxes, deadlines, and group chats. And somewhere underneath all of it, that same ancient part of your brain is still standing guard, still listening, still ready to run, even when there's nothing out there at all. This has been today's deep, meaningful talk. Hope you enjoyed the DMT. The deeper you look, the stranger things become. Until next time, keep asking why.